Hello learners, till now I have tried to make you familiar with the concepts of control system, then modeling of the control system by using the differential equation, by using the transfer function in my previous lecture. Then first of all, we'll discuss what are the disadvantages of the transfer function approach. So transfer function is what? This is the ratio of the Laplace transform of the output to the Laplace transform of the input variable. It is simply representing a relationship between input and output. It is not giving us insight into the system performance. Then when we are deriving the transfer function, then we are considering zero initial condition. At the same time, we are saying that transfer function can be derived for only linear time invariant systems. Zero initial conditions are not always possible. Then obviously there are certain initial condition associated with the plant. Capacitor there may be initial some charge left on the capacitor. There may be some energy available on the inductor element. There may be some inertia within the mass element of the mechanical system. So zero initial condition concept that is not always that cannot be always followed. Then second thing is all of the system that we come across in our day-to-day life or around us, they are non-linear ones. We cannot, in case we are saying that we are analyzing them by using the theory of linear time invariant systems, then that is wrong, because the system around us, most of them are having the features of saturation associated with them. Then when we are using the electronic system, there we are using the semiconductor components. All of them are having the nonlinear characteristics. A number of components that we we are using in the mechanical system, like we are using a gear system, then there is certain gap between the driver and the driven pulley. So that leads to the nonlinear characteristics, that leads to the dead zone, means there is not output produced, although input is there. So transfer function concept can only be used for the linear time invariant system only. And what about these systems that are around us? For modeling such system, we require certain other technique. Then transfer function concept is applicable to only CISO system, single input and single output. And most of the control process that we are using in the industry, they are multiple input, multiple output system. So for having a for having a modeling of such systems which are not linear, which are not time invariant, the systems where we have to take into account multiple input and multiple output, we do not have any other option left uh, than using the state variable approach. So what is a state variable approach? That I'll be discussing within this lecture. And actually this is a broad topic, so it will be taking certain more time. So I have divided this complete lecture into 3 parts. So this is the first part that is associated with the analysis of the state variable technique. So what is state variable analysis? This is an excellent method for the design and analysis of the control system. And the previous method, we have already said that this was the transfer function method. The transfer function method had a number of drawbacks, like which become advantages of the state variable analysis. Like the transfer function approach cannot be applied to the nonlinear system, but state variable approach can be applied to the nonlinear system. Transfer function can be applied to the modeling, can be applied to the only time invariant system, and the state variable analysis approach can be applied to the time variant system. I'm sorry for being the mistake over here in this. It can be applied to the time variant systems. Then transfer function approach is applied to the single input, single output system only, but state variable analysis approach can be applied to the multiple input, multiple output systems. And transfer function is not giving any idea about the internal state of the system. In state variable analysis, it is up to us to define the variables which are representing the state of the system at any time. So we can get the idea of the internal state of the system at any time. Then what is state? Basically, we are seeing the state model. Then what is a state? State is basically the when we talk about the dynamical system, a system that keeps on changing its state from time to time. So state of the dynamic system, it is the smallest set of variables such that the knowledge of these variables at any time t equal to t naught along with the knowledge of the input for t greater than t naught completely determines the behavior of the system for any time t greater than equal to t naught. So this is termed as the state. So state is represented with the help of a state vector, and state vector are chosen by us. Like in case I'm having a mass m that is applied with the force F, then the state variable is how I represent the state of the system at any time. What is the position of the mass at any time, and at any time with what velocity it is moving. So I can take up two state variable, that is position, and second is the velocity. So anyone else can use other state variables, but the condition is that the state should be represented by a minimal set of variables, because as the number of variables increase, the total calculation time will also increase. Then the second thing is that the chosen set of state variables should completely describe the state of system at any time. So then is the state vector. State is represented with the help of the state vector, and state vector consists of a number of the state variables, and those state variables are chosen by the user, and the state vector is not unique. It will depend upon user to user, but you have to ascertain that whatever state vector or state vector you are defining, that should completely describe the state of the system at any time. So then these variables can be represented in a space that is termed as a state space. So in case we have a block diagram of a linear continuous time control system, it is this is shown over here. This is ut is the input, yt is the output. Then in between we are having certain feedback elements and other blocks present as shown in this block diagram. If we want to get the state model, then it is represented by two sets of equation. First is called the state equation. The other one is called the output equation. The state equation is giving the way the state of the system is changing with time. And the second is this is the state equation. So how the state is changing. So x dot t is representing the rate of change of the state variable. So it is all these quantities. Now, like when we say xt, ut, these are all and yt, these are all vectors. Then a, b, c, and d, they are all matrices. So this x dot t is equal to axt plus ut. It is called the state equation. It tells that how the state of the system is changing with time. Then yt is equal to cxt plus dut. It is the output equation. And both of these state equation and the output equation together represent the state of the system at any time. So if we are having because we have already said that we are having a system, then the simplest model that we can get, simplest mathematical model that we can get, this is the this is with the help of the differential equation. So this is with the help of the here we are represent this particular system, this particular difference equation. Let it is representing the state of the system. So this is the difference equation, because in the case of the continuous mode of operation, we are having the differential equation, but in the case of the discrete mode, when we are using and we want to represent the system dynamics, that is done with the help of the difference equations. So this is the overall a difference equation that is representing the dynamics of the system. U is the input and y is the output, and it is represented with the help of the this one. So with the help of this equation, here it can be a differential equation in case we are taking yn is equal to y within bracket n. It can be a differential equation in case we are representing yn as the derivative, nth derivative of y. So this is in case it is nth derivative of y, it will become a differential equation. In case n, this is y within bracket n, then it will become a difference equation. So let us consider that this is a differential equation. So in that case, we'll just take up the state variable like this. First state variable y, x1, that is taken as equal to y. Second state variable is first derivative of y. Third state variable is second variable of y. Then similarly, nth variable will be calculating. This is the this will get as the n minus 1th derivative of x. So this is dxn minus 1 by dt. So it is represented as x1 is equal to y, x2 is equal to dy by dt. So this is dx1 by dt. Just this is to be correction. So x2 is equal to dx1 by dt. Similarly, x3 is equal to dx2 by dt. Similarly, xn is equal to dxn minus 1 by dt. So the equation becomes just like this. X1 dot is equal to x2. You can see over here. This is x1 dot. This is x1. Please read it as dx1. So x1 dot means derivative of x1 with respect to time. So this is equal to x2. First state variable we have just defined. X1 is equal to y. And the second variable we'll just keep on defining as the derivative ones. So x1 dot is equal to x2, x2 dot is equal to x3 up to xn minus 1 dot is equal to xn. So we'll be able to define the derivative of n minus 1th state variable like this. After that, we have to get the derivative of the nth state variable, and for that, what we'll be doing? We'll be using the basic state equation. So yn minus 1. So this is equal to xn minus 1 into that. So this is xn minus 1 dot, xn minus 2 dot. So this is y1. So this is equal to y will be represented as x1, and this one y1 will be represented as x1 dot, and so on. We'll just put up in this way within this equation, and we'll get the value of xn dot. So it can be obtained from the equation. So the procedure becomes what? That first of all, whatever variable you are using, you'll take up its it as the first state variable. Then second state variable will be the first derivative of the this output. Third state variable will be the second derivative of output or the variable that is involved, and so on. We'll keep on defining. So since we have to obtain the state variable, that is x dot, so we'll require x1 dot, x2 dot up to xn dot. So from this equation, we can write down x1 dot is equal to x2, x2 dot is equal to x3, x3 dot, and we can get up to xn minus 1 dot. But in order to get the value of xn dot, we have to keep into account this equation. From here, we will be able to write the value of the xn dot that we have written over here. Once we are having this representation, we can have the state variable representation. State variable representation or the state variable modeling consists of two equations, that is the state equation and the output equation. State equation is this, so we just substitute the value x1 dot, x2 dot up to xn dot. So it will be x dot t is equal to x1 dot, x2 dot up to xn dot. This is equal to a into xt. So we'll be having, since x1 dot is equal to x2, so we'll get a 1 over here. This is xt is x1t, x2t up to xnt, and there is no dependence on u of all these n minus 1 variable. There is dependence on u of only nth state variable. So we'll get b as equal to 0, 0, 0, 0, 1, 0, 0, 0, 0, 1 and a as equal to minus, within this x1 dot is equal to x2, so we'll get a 1 here. X2 dot is equal to x3, so we'll get a 1 here, and so on. Xn minus 1 dot is equal to xn, so we'll get a n here. Then xn dot is equal to minus an x1, so minus an minus 1, and so on up to minus an. Then in for b, we'll be having 0, n minus 1, 0, and within last you'll get a 1. So we are able to get the state variable model. So what we have done, we have defined the state variable, then we have determined the value of matrices A and B. Then similarly, in order to get the output equation, we are having the output equation represented as yt is equal to c into xt. In case the output is y, so it means that yt is equal to 1 multiplied by x1t that we had taken. Here we had taken x1 is equal to y. So y is equal to x1. When we represent it in the matrix vector form, it will come out to be yt is equal to cxt. So it will be represented as C matrix will come over. C matrix or vector in this case, it will come out to be of this form. Then we just take up a particular mechanical system and we want to get the state space model of this mechanical system. On this, we are having a mass m on which a force FAT is working and it is producing a displacement x in this, and similarly it is producing a displacement y over here. So and we want to get its state space model. So for that, first of all, we have to draw its free body diagram that is represented over here, and from this free body diagram we'll write down the equation of differential equation describing the state of this system, and considering the mass element and then considering the second element. So we get the two differential equation which are describing the state of the system. Then we define the state variable. First state variable, we have just taken the displacement of the mass. Then second is the velocity, and the third one is the second displacement in the second element. So three state variables we have defined, and from the differential equations that we have already made, we have got the value of three state variable q1, q2, q3. Then we have got their value q1 dot, q2 dot, q3 dot that we have derived from the differential equation. And then we have just tried to return q dot is equal to a into q1 plus b into u. So q dot is equal to a into q plus b into u. So if we just put up all these values, we'll get the value of A matrix as is equal to this, B matrix vector as equal to this, C vector as equal to this, and D as equal to 0. This is the way we get the state variable modeling of the mechanical system. So within the next few lectures, I'll be discussing that how do we get the state variable modeling of the other systems also. So just keep on watching. Thanks a lot for the patience learning and patience listening to me.